Hello and good evening to all of you. I hope all of you are doing well and all of you are in good health. If you remember in the previous class, we had acquainted ourselves to important statistical measures, which included measures of central tendency, measures of asymmetry, measures of dispersion, and measures of relationships. Then onwards, we discussed the importance of measures of central tendency, and we also discussed the various statistical averages like mean, median, and mode. Then we also discussed the applicability of each of these statistical averages. Moving forward, in this class, we will discuss measures of asymmetry and measures of dispersion. Now let us try to understand measures of asymmetry. The data values in the data set is expected to have symmetrical distribution along the measures of central tendency. But in certain situations, the data values in the data set may exhibit asymmetric distribution or skewness. Now let us learn about symmetric distribution and different form of asymmetric distribution or skewness that may be exhibited by the data values in the data set. To begin with, let us try to understand normal distribution. Normal distribution is a distribution that has mean equals to median equals to mode, which implies data values in the dataset are symmetric about the center or distributed symmetrically about the center, which further implies 50% of values are less than that of mean, whereas 50% of the values are greater than that of the mean. Now let us move on to different forms of asymmetric distribution. Negative skewed distribution or left skewed distribution is a type of distribution in which more values are concentrated on the right side of the distribution graph while the left tail of the distribution graph is longer, which implies in case of negatively skewed distribution, mean is less than median, which is less than mode. Now let us move on to positively skewed distribution. Positively skewed distribution or right skewed distribution is a type of distribution in which more values are concentrated on the left side of the distribution graph while the right tail of the distribution graph is longer. This implies in case of positively skewed distribution, mean is greater than median, which is greater than mode. Now let us try to understand these three forms of distribution with the help of an example. Now let us consider normal distribution. Let us consider the following data set. The data set has 4, 5, 6, 6, 6, 7, 7, 7, 7, 7, 7, 8, 8, 8, 9 and 10. So here mean is equals to 7, median is equals to 7 and mode is also equals to 7. So this is an example of normal distribution. Now let us try to understand negatively skewed distribution or left skewed distribution with the help of an example. Consider the following data set: 4, 5, 6, 6, 6, 7, 7, 7, 7, 8. So here mean is 6.3, median is 6.5 and mode is 7. So in case of negatively skewed distribution, mean is less than median, which is less than mode. Now let us move on to positively skewed distribution or right skewed distribution. So here let us consider the data set 6, 7, 7, 7, 7, 8, 8, 8, 9 and 10. So here mean is 7.7, median is 7.5 and mode is 7. So here mean is greater than median, which is greater than mode. So this is an example of positively skewed distribution. Now let us move on to the equation for skewness. So skewness is equals to sum of cube of the differences between the data points and the mean divided by the product of total number of instances and cube of the deviation. So here skewness has two equations. We have skewness for population and skewness for sample. In case of skewness for population, we'll use n, or the total number of instances in the population, and in case if you're determining skewness for sample, we'll use n minus 1. Now let us try to understand how to interpret the value of skewness. So if the value of skewness is between minus 0.5 and 0.5, then it is understood that data are fairly symmetrical. If the value of skewness is in between minus 1 and minus 0.5, which represents negatively skewed distribution, or between 0.5 and 1, which represents positively skewed distribution, the data are moderately skewed. If the value of skewness is less than minus 1 in case of negatively skewed or greater than 1 in case of positively skewed, the data are highly skewed. So this are the different interpretations of value of skewness. Again, if it is between minus 0.5 and 0.5, it is considered to be fairly symmetrical. If it is between minus 1 and minus 0.5 in case of negatively skewed, and 0.5 and 1 in case of positively skewed, then it's considered to be moderately skewed. And if it is less than minus 1 in case of negatively skewed and greater than 1 in case of positively skewed, then it's considered to be highly skewed. So these are the different interpretations of values of skewness. Now let us move on to measures of dispersion, wherein we will be discussing range, standard deviation and mean deviation. Now let us start with range. Range is the simplest possible measure of dispersion, which represents difference between the value of extreme items of a series, which implies range is equals to highest value of an item in a series minus lowest value of an item in a series. So this is the way how range is determined. Now let us move on to mean deviation. Mean deviation is the average of difference of the values of items from some average of the series. Now mean deviation can be determined from mean or median or mode. So here x bar represents mean, M represents median and Z represents mode. So in case of mean deviation from mean, we find sum of all the differences from mean of the data points and divided by the total number of instances. So here we will be considering only the magnitude of the differences in order to determine the mean deviation. Likewise, mean deviation from median will be sum of differences of the data point from the median divided by the total number of instances. Likewise, mean deviation from mode will be sum of differences of the data points from mode divided by the total number of instances. So we can find mean deviation from mean or median or mode. Now let us move on to standard deviation. Now standard deviation is one of the most widely used measure of dispersion. Standard deviation is defined as the square root of average of squares of deviation. So standard deviation has the following equation. It is the root of sum of squares of differences from mean divided by total number of instances. So this is the equation for standard deviation. So here I have given you the example of how to determine standard deviation. So here we have 10 values in the data set. So standard deviation is determined using the formula that we have specified in the previous slide. So in this class we have learned about measures of asymmetricness, wherein we have learned about symmetrical distribution and asymmetrical distribution. We have learned about normal distribution. We have learned about negatively skewed distribution and positively skewed distribution. We have tried to understand each of these forms of distribution with the help of examples. Then we moved on to the equation for skewness. We have also learned about how to interpret the value of skewness. Then we moved on to measures of dispersion, wherein we discussed range, mean deviation, and standard deviation. So in the next class, we will be discussing measures of relationship, wherein we will discuss variance, covariance, and correlation. Thank you very much and have a very good day.